So let's talk about one of the most important patterns in distributed systems, the Saga pattern. If you've ever worked with microservices and tried to handle transactions across multiple services, you already know it's not easy. In a traditional monolithic app, it's simple. You just start a database transaction, perform a few steps, and either commit or roll back. But in a microservices setup, you don't have one shared database. You've got multiple services, each with their own database and logic running independently. This makes things tricky when you need a long-running transaction, something that spans across more than one service and needs to remain consistent. That's where the Saga pattern comes in. Let's break it down with a real-world example. Picture this. You are building an e-commerce platform. A customer places an order, and behind the scenes, several services need to kick into action. Here's the typical flow. First, the order service creates a new order in a pending state. Then it calls the inventory service to reserve the items. After that, it talks to the payment service to charge the customer. And finally, it confirms the order. Now, what happens if step 1 succeeds, step 2 succeeds, but step 3, the payment fails? You've already reserved the items. You've marked the order as created, but the payment didn't go through. So now you've got inconsistent data, a half-complete transaction spread across multiple systems. The Saga pattern fixes this by breaking the transaction into smaller local transactions, each handled by one service, and coordinating them using either choreography or orchestration. Let's use orchestration for this example. It's easier to follow in a video. So in our system, the order service plays the role of the orchestrator. When the customer clicks place order, the order service begins the Saga. It creates the order and then sends a command to the inventory service, reserve the items. The inventory service does its part. Maybe it reduces stock or marks the items as held. If that succeeds, the order service then calls the payment service to process the payment. But here's the important part. If anything fails along the way, like the payment fails due to insufficient funds, the orchestrator triggers compensating transactions to undo the previous steps. In this case, it would send a command to the inventory service to release the reserved stock, and it would update the order status to cancelled instead of confirmed. This way, the system stays consistent even though each service is managing its own data. No global lock, no distributed transactions, just smart coordination and undo steps. That's the core idea behind the Saga pattern, managing consistency through events and compensating actions rather than database locks. If you are working with microservices, and especially if you are building anything that looks like a workflow where actions depend on one another, learning the Saga pattern is critical. There are plenty of tools that can help implement it too. In the Java world, you might use Spring Boot with a message broker like Kafka or RabbitMQ, or orchestration engines like Camunda, Temporal, or Netflix Conductor. But the concept stays the same. Break the workflow into local steps, coordinate them with events or commands, and always have a plan for what to do if something fails. That's how you keep a distributed system strong, stable, and consistent, without giving up the flexibility that microservices give you. Thanks for watching, and I see you in the next one.